Okay, so to continue, we have renamed those planes as shading planes. So we have them right here. So now is the time to do the windows. So again, I'm going to use the same method. I will add a plane. Now, one thing to know about windows in OpenStudio and EnergyPlus is that they are not actually holes that are cut out of the surface. They are just simply subsurfaces that are coplanar with the parent wall, and they just are like almost like stuck on them like stickers. So the original wall stays whole as it is, and then you just simply put another plane, which is the window, and it's coplanar with the wall. So for this window, I'm going to first of all rotate it by 90 degrees around the x-axis so that it's standing up. And in terms of the dimensions, I am going to make it 8 meters in the x and 1 meter in the y. Okay, now the first one, in terms of the position, I'm going to place it at the midpoint here at the centroid of the surface. So we know this is 10, so this will be 5, and we know this height is 4, so this will be 2, so basically 5, 2. So let's see if that works. We put it at 5 meters, we put it at Z of 2 meters, and there it is. So let's just simply check our work, make sure it is correct. Looks fine. So that would be the window here. So I'm going to repeat this ribbon window up again, similar process that we did before. I will add an array modifier, and I will make sure that it is a constant modifier, constant offset, 0, and then it should be 4 meters. Oh, what happened here? It's going in the wrong direction. So now Z is 4 meters that way. So okay. So basically, let's try the Y direction for it, because we've rotated it, it looks like. And right, why is the Y not correct? So let's see. We say 8 meters looks correct. So why is that? Not 100% sure why that distance is 8 meters, but it looks like it's reaching the correct height. Let me just add the count. It definitely is working, but not 100% sure why. The rotation obviously has messed it up a little bit. In any case, if that works, that works. Right, so we're going to do the same thing. We're going to go ahead and export this as FBX, and I'm going to call it South Window Planes, and it's a selected object. And I will delete it and bring it back in. Import FBX. South window planes. There they are. So we can repeat the process for all the other windows, but for now I'm just going to leave it as is. And so the next step would be to start creating the needed cell complex for TopologicEnergy. So let's go ahead and do that. This is a good time to save. So save as, and let's put it on the desktop, and let's call it TopologicEnergy tutorial video. Save it. Right. So we're going to change the layout to be a scripting layout so that we can add the visual nodes. So here it is. And just bringing this view, we can make this view a little bit larger and hide these things a little bit, and maybe push this a little bit like this. Right. Go back maybe to the X-ray mode. to be able to see everything. And now we can change this editor type to be the spur chop nodes, because that's what we will use. And we can hide these a little bit. And we can start a new definition, new node tree. And you'll notice that we have topologic here, and we have all the other nodes for spur chop. So let's go ahead and start bringing in some entities. So I'm going to start with the perimeter. So how do we bring it in? We go to Scene. For this one, we can use Get Objects in Light. So we can do that like this. And because it is selected, if we say Get, you will notice that the name here is perimeter. Now, how do we make a topologic cell out of this? First, you need to apply the matrix that's here, because this might have been moved or rotated or scaled. So we need to apply the matrix before we move it to topologic. So we do matrix, matrix apply. Let's put it next to it. And we connect the vertices, the edges. The polygons become faces. And then the matrix is connected to matrices. From here, we can use topologic bigeometry. One fast way to do it is to hit Alt spacebar and search for it. So topology.bigeometry. We can put it next to it here and connect the vertices, edges, and faces. If we want to check our work, we can do a stethoscope, which tells you what kind of topology we got. And it says that we got a cell, which is exactly correct. So we can take these, all 4 nodes, and we can put them in a frame, group them together, and let's go ahead and change the name of this frame to perimeter, because that's the perimeter. Okay, so now what we can do is copy all of these. Oh, sorry. It's kind of weird, yeah. If you copy the perimeter, it's only the frame. So you need to actually select the whole thing. And Control-C, Control-V. Put that somewhere here. And I'm going to drop this and now get the core. Alright, so excuse the break in the video. We did the same thing. We copied this over. We're going to change the name of this to core. And we got the core cell here, so it's also a cell. So there it is in the middle. And we're going to continue doing this to get the rest of the entities. So next I'm going to get the diagonals. So let's put that here. We'll call that diagonals. And we're going to drop the core, choose the diagonals. Right, so let's actually, let's go ahead and get the slicing plane, because the diagonals I'm going to get in a different way. So I'm going to go ahead and take the slicing planes. Sorry, this one went diagonal, so that should have been the core. It's named the wrong one, sorry about that. So put that back to core. This one should be called the slicing planes. And we're going to get the slicing planes, and that's the cluster. The shading devices, we can do the same for those. So let's go ahead and do that. And this one should be called shading planes. And we're going to drop the slicing planes, get the shading planes into it, and that's also a cluster. So that's correct. Now for the diagonals, because they are separate, what we are going to do is, you know what I'm going to do is do the same for the diagonal plane. So I'm going to make them into one entity. So let's go ahead and do that. So the diagonals are here, so they're selected. I'm going to export them. No, I think they will not come back. No, sorry. I think there will still be multiple entities if I do FBX. So sorry about that. I'm gonna just go back to the original plan. So here's what we're gonna do. We're gonna copy these one more time, but we're going to first of all delete this frame and delete this object in, and let's go ahead and get something else. We have something called get objects data. It's a little bit more advanced. So the objects data can get the selection here. So we have all four of them selected. So they're all in here. We can join them. That's fine. They're going to be joined. So we're going to join the vertices, the edges, the faces, and then the actual matrix. And you'll notice that we have a cluster. So we can take all of this. Let's move it a little bit closer. And then join that in a frame. And let's go ahead and name this frame diagonals. And it's a cluster of faces. Great. So now we have everything. So how do we check our work? So what I'm going to do is hide all of these things. Let's continue hiding. Alright, so we have hidden everything as input. And let's find out what the output is. So from Topologic, we can go back out to Blender. So let's go ahead and do Alt spacebar topology.geometry here. And maybe it's a good time to save. You never know. So Control S, and let's go ahead and connect the topology. And then one trick is to do a control click on it, which gives you a temporal viewer. A temporal viewer is like, think of it as a temporary viewer in a way. It doesn't actually add to the scene, it just simply displays it onto the screen. So this is the perimeter cell, which is fine. If you want to make it translucent or transparent, whatever you want to call it, 0.5, you can change the alpha on the color, and you can see how it is. So now if I keep reconnecting the other one, so let me reconnect the core, for example. Oops, sorry. Here is the core. Here are, let's go ahead and lower this a little bit so that we can connect it. So let's connect the slicing planes just to see them. So just a visual check that Topologic has recorded them correctly and is outputting them correctly. I still have shading planes twice here. Why? So these are shading planes. What are these? Are these the diagonals? No. Oh, I have two shading planes. That's kind of weird. So okay, so we don't need this. I don't know where it came from. Sorry, I'm not paying a lot of attention, it looks like. So let's go ahead and look at the diagonals. And the diagonals are there. Perfect. Okay, so now comes the time to create a cell complex. So how do we do that? So the first thing I'm going to do is I'm going to slice the perimeter with the slicing plane. So if you will indulge me, I'm just going to put the slicing plane second. I'm going to move them here because the core is going to come after that. And the shading planes are actually at the very, very end. We're not going to even add them because they just get added to the energy model. All right. So we're going to take the perimeter and slice it with the slicing plane. So what is the node for that? That's called topology.boolean. And from this Boolean node, you can choose the Boolean operation. So here we're going to choose slice, and we are going to give it the perimeter, and we're going to give it the slicing planes as a cluster, and let's take a look at the end result. Here it is. So those are nicely sliced. It's a cell complex. So if you notice, if I take the stethoscope, make a copy of it, and connect it, this will be a cell complex. Fantastic. So now for the core, I can impose the core onto it. So I can go ahead and again use the same Boolean operation, but change it to, or the same Boolean node, but change the operation to impose. And I can take the resulting cell complex and impose the core. So what does imposing mean? Impose means that topology B that is being imposed is not modified. It gets to be exactly as it is, and it gets inserted into topology A. So almost imagine, for example, you have a tub of ice cream and you're putting a scoop handle into it. The ice cream gets segmented, but the scoop stays the same, and it's very much the same thing. Or if you imagine putting a solid or a rock into a glass of water, the rock does not get modified, but the water kind of gets enveloped around it. And this is what impose means. So I'm going to go ahead and impose the core, and again check the end result. Ooh, there's an exception here. Let's see what is going on. Core, matrix, exception error, the operation has failed. Interesting. Okay, I will pause and come back and see what's going on. Okay, I took a look at it, and I don't know why. When I disconnected and reconnected, it worked. So I don't know if it's a little bit of a bug, but let's go ahead and try it one more time and see what it will do. So obviously, this is the topology A, the cell complex. This is topology B, the core, and now it worked. So not sure if I connected the wrong outlet first or did something. I'm not 100% sure. In my experiment, it was working just fine. So right now, this should also be a cell complex, and indeed, it is a cell complex. But the nice thing about it is that the cell in the middle is not interrupted. So let's go ahead and check that. So I'm going to count how many cells I should have in this cell complex. The perimeter is one cell. So we have 1, 2, 3, 4, 5, 6, 7. And then we have one cell in the middle, that's 8. So I should have 8 cells. So let's go ahead and add a topology.analyze to check our work, and then get a stethoscope to look at the textual result. There we have it. This is a cell complex with 8 cells, 8 shells, 66 faces, 74 wires, 120 edges, and 64 vertices. So nothing is repeated. Everything seems very clean. So that is really good news. So we can continue our work. So let's go ahead and delete this. Okay. So now we need to add the diagonals. And from my experiments, I found out, that the best thing to do is grab all the faces and then rebuild the cell complex with all the faces. So I'm going to try to do that. So I'm going to do a topology.subtopologies. And now I just remembered that the faces that I deleted that should have been the windows. So we'll do that in a second. So let's get the faces. So topology.subtopologies, and you choose which one do you want. So we want to get the faces out of this cell complex. And again, if I do a stethoscope, you'll notice that I have all the faces. There are 66 of them. And if I get also the faces of the cluster, of the diagonals and do a stethoscope on that, and I should have these 4 faces. So if I do now a list.join, join the 2 lists together, the 66 from here and the 4 from the diagonals, I should have 70. Yeah, 70 faces. And what I'm gonna do now is build a cell complex with all these faces that I have. So cell complex by faces, and let's visualize the result. So I'm gonna take the viewer that I had used before and the stethoscope and use those here. We don't need this one. So let's go ahead and first of all check that we do have a cell complex. Indeed, we have a cell complex. Let's go ahead and visualize it. And there it is. It seems all good and clean. One way to see the edges is to hide the display polygons and check your work. Make sure that it is all extremely clean. Let's do one more check on the number of cells, because that is the kind of the proof that it worked. Again, we have 4 cells on each level, so 4 times 7 is 28, plus 1 continuous cell in the middle. That should give us 29 cells. So let's go ahead and do a topology.analyze onto the cell complex, and let's get a stethoscope on it, and here it is. It says we have 29 cells. Okay, fantastic. So we're almost there. What we really need to do, which I omitted from the earlier steps, is to do the windows. So the windows are, if I'm not mistaken, where are they? They're called still plane, I think. Yeah. So let's go ahead and change their name to windows. I've ignored those till now. So I'm going to move these things down a bit and copy this shading planes. Again, I do the same mistake. Apologies for that. I should highlight it like this and drop these, and let's go ahead and get what is being selected, which is the windows. All right. And again, it is a cluster. So how do we, let's hide these things so that we get a bit more real estate here. So how do we add these windows, which in topologic speak are called apertures? How do we do that? So first of all, let's get the subtopologies, and let's get the faces. So out of this cluster, we get the faces. We should have 7 faces. Yep, 7 windows. And there is something called Add Apertures. So let's try that. So Topology Add Apertures. So what is the topology? The topology is the cell complex, the final cell complex, which is right here. And the apertures are these faces. And it says it's exclusive. That's absolutely fine. So let's go ahead and check our work. So now this is the final cell complex. As you can see, everything's still the same. But how do we know that these windows are there? So I'm going to first of all hide them. So if we get the faces of the final cell complex, this is the final cell complex here. So let's go ahead and do the subtopologies and do faces. So let's get the faces. These are all the faces of the cell complex. Obviously, most of them, the vast majority, do not have apertures. But then let's get the apertures of the topology and check our work. So it's 118 faces, and you'll notice that some of them have apertures. So let's go ahead and draw those. So let's get these. And you'll notice here are the apertures coming out of the cell complex. So the cell complex has faces. The faces, or some of the faces, have apertures, and they are here, and they come out correctly. So when you send this cell complex to TopologicEnergy and to OpenStudio, these apertures will be recognized and will be treated as windows. So I'm going to stop here, and then the next video I will show you how we actually build and simulate an energy model. Thanks for watching.